Hello everyone, myself Alok Kumar. I am assistant professor in Government College of Engineering, Dharmapuri. So here we will see next topic, that is regular expressions to automata and minimization of Dfa. So here we will see regular expressions to Dfa conversion. So this one we can do in 3 steps. Firstly, we will convert regular expression into a empty Nfa, and after that empty Nfa into a Nfa, and finally we will convert Nfa into a Dfa. So you can see here regular expression. Firstly we are going to convert into empty Nfa, after that this empty Nfa into Nfa, after that this Nfa into Dfa. So here you can see regular expressions to empty Nfa. So some rules we have mentioned for converting from regular expressions to empty Nfa. For empty string, here you can see from initial state to final state, using empty string we can go. For input A, suppose, so from initial state to final state we can go using A string. Suppose we have to do union of 2 regular expressions. So how we will do? We can do this like initial and final, and here we have to keep 2 states, and here also we have to keep 2 states. You can see with this example 0 plus 1. So this one is initial state, empty, 1 empty, this one is final, and plus 1, that is OR. So empty, 0, empty string. So for concatenation, suppose 2 regular expressions are there, like we can see with this example AB. So A and B, or we can do A empty string B. Like this manner also we can do concatenation. Suppose for closure, or we can say clean star, suppose we have to do, so we will do initial state and final state, and in between we will do this for closure. So here this one is 0 plus 1 closure. So initial state here, and this one is final, and in between 0 plus 1, this one is 1 and 0, and this one is from this state to this state we have done transition using empty string. So this one is 0 plus 1 closure. We will see this one with all these rules we will apply on one example. So suppose this one is example we have taken, create a empty Nfa for regular expression A or B, closure A. So firstly what we will do, we will find the empty Nfa for A or B. So like this manner, empty A, empty, and this one is empty B, empty. Like this manner, A for A or B we have found empty Nfa. Now if we want to find the closure of A or B, so how we will do? So like this manner, this state we have added with this one, and this one is finally state. So here after that from 6 we are making one transition using empty string. So this one is the closure of A or B, closure. After that this one is we have concatenated A also. So after that, after this one here A also we had added, and here we have made this one as final state and 0 as initial state. So this one is a empty Nfa for A or B, closure A. Now next we will see how we will convert empty Nfa to Nfa. Okay, so we need to eliminate the empty transition by subset construction. So using subset construction we will eliminate the empty transition. Suppose we have taken one example, this one. So this one is empty Nfa. So what we will do, we will find the empty closure of each state. So empty closure of Q0 for this example is using empty string from Q1, Q0, where we can go Q1 and Q2, and in that state itself we will also count. So here Q0, Q1, Q2. From Q1 using empty string, where we can go? Nothing, only Q1 will come here. From that state to that state will be counted in empty closure. From empty, for empty closure of Q2, that also will be Q2. For empty closure of Q3 will also be Q3, and empty closure of Q4 will be Q4, because from Q4 using empty string we are not going to any other state. So this first step we have done, empty closure of each state we will find. After that we will say, like suppose empty closure of initial state we are saying as state A we have said here. So after that we will find the we will find for NFA. So for this one we will find the transition, like how we will do delta transition A, this one, this state we are saying, and this one is subset construction rules. So A, from this, for A we are saying Q0, Q1, Q2, and using 0 we are going empty closure we are finding. So we will find Q0 0, Q1 0, and Q2 0. From Q0 using 0 where we are going, from Q1 using 0 where we are going, from Q2 using 0 where we are going. So we will find that here we are going to Q3. Okay, so this one state, another state we are saying, let this state as B. After that, here we will find like this manner. For this one we have done is using 0 where we are going. For Q0, Q1, Q2 using 1 where we are going, we have found here. So like this manner, Q0, Q1, Q2 using 1. So Q0, from Q0 using 1 where we are going, from Q1 using 1 where we are going, from Q2 using 1 where we are going. So when we are finding empty closure, so it will come Q3. So that state already we have said as B state. So now if we are making this NFA we are making, so here partial NFA will come like this manner. A, and from A using 0 where we are going to this B, and A from using 1 where we are going B. So like this man, this one is half of NFA. Now here again we will find for B state, from B state using 0 where we are going, so we will find this one is 5. So nothing we are going. So after that using B state, from B state using 1 where we are going, so we have found closure. So here Q4 is coming, so that is we are saying as state C. And after that for state C also we will find the empty closure. So this one will be the final NFA. So like this manner, from A to B we are going using 0, from A to B we are going using 1, and from B to C we are going using 1. So here this one is the NFA. Now here we will see how we will convert NFA to DFA. Suppose we are taking this one example. So firstly what we will do, we will construct a transition table for this one. So for initial state Q0 where we are going from using 0, so Q0 and Q1. So like this manner we have mentioned. From Q0 where we are going using 1, that is Q1, like this manner. From Q1 using 0 where we are going, nothing we are going, so that we will keep as 5. And from Q1 using 1 where we are going, Q0 and Q1, so we will mention here. This one is initial state and this one is final state. That's why we have mentioned this one is for initial state symbol and this one is for final state symbol. Now we will find the transition for state Q0. Okay, so that from state Q0 using 0, this one we are going Q0, Q1, like this manner we have mentioned here. Okay, now for state Q1 also same manner we have found. So suppose we have to find here DFA. For that one we will find the transition on this state also, Q0, Q1, new state. So we will see here from this state Q0, Q1 using 0, this one we will find this closure. So at the time Q0, Q1, from Q0, Q1 using 0 we are going to same state, and like this manner from Q0, Q1 state using 1 we are going to Q0, Q1 same state. So like this manner we will find this closure we will find. Okay, so after this one this table is going to come. So this one is transition table that we will say as a we will use for constructing DFA. So this one is the table, and using this one we are making here transition diagram that we will say as DFA. So from Q0 using 0 we are going to Q0, Q1, this is state. From Q0 using 1 we are going to Q1. Okay, now from Q1 using 0 we are going to 5. This is the dead state. Okay, and Q1 to 1 we are going to Q0 Q1, and from Q0 Q1 using 0 and 1 we are going to same place. So this one is the conversion of NFA to DFA. Next we will see minimization of DFA. So suppose we are taking here one example like this manner. So for this one, what we will do, firstly we will see whether any unreachable state is there or no. So using this diagram we can see Q2 and Q4 here. These two are the unreachable state, because from any other state to Q2 Q4 we cannot go. Okay, so these are unreachable states, so we will remove that states. So that will be our first step. After that, what we will do, we will draw a transition table. So for this one, this is the transition table. Here Q0 is the initial state and Q3 and Q5, these are the final states. So we have made this transition table. Based on this one, what we will do, we will find one, we will separate this transition table into two tables. One is non-final states and one is final states. So we will divide this one into one set contains two rows, that is non-final states, and these two rows here, these are final states. This one will be our third step. After that, in fourth step, what we will do, in suppose here this we are saying set 1 and this one is set 2. So here we will do whether, suppose in this one set 1 two rows are there, we will see whether both rows are similar or no, and in same set B we will see whether two rows are similar or no. So based on that one, if two rows are similar in any set, then we will remove any one row. So like this manner we have seen in set 2, row 1 and row 2 both are similar, so one row we will remove. So like here you can see, so one row we have removed. So we set 2 we are getting like this manner. Now we will combine set 1, this one and this one, so we will get this, and this one will be the minimized DFA. So this one is the last topic, that is minimized DFA. So next unit we will see in further lectures. Thank you.